Hi.
Hello.
It's the end. We're the only thing in between you and escape.
So, this is your slide.
It is my slide. So what is this talk not about? It's about ethics. But I think it's pretty important when you talk to people about ethics that you don't pretend to be an ethicist. I'm not a professional ethicist. What is a professional ethicist anyway? But telling you what to think or what to do, trying to outline what is right and what is wrong, not the goals of this. It's more to give a framework of how to think about those things. I'm certainly not trying to change your values. We're very in a unique place here. I've given ethics talks all around the world, but this is the first one that is in the East. So I think there's some pretty interesting societal differences where like a deep discussion of differences in values would result in some pretty interesting differences. So don't want to go there. And we're not going to recap a code of ethics line by line. What we want to do instead is provide a good set of perspective on how you should be considering ethical considerations in software engineering, software design. So what should you be looking at? So good question is how many people think of ethics concerns and the things that they do on a daily or weekly basis? So it's an encouraging number of hands at probably about 5%. So I want it to be 80% plus.
So lenses to see the world through. I mean, that's the goal of this talk. So a quick word about us. I'll introduce Theo. We've never worked together, so we don't work in the same place, but we have both been involved with USENIX for a while, Theo longer than myself. Theo is an extremely distinguished engineer and cares deeply about professional ethics.
And Laura has a very unique perspective on this as she has left a job due to ethical reasons. Apparently we're also on stage at an SRE conference because we both contributed material to SRE books that you may have read.
Oh. Ha. Right, this is going to go horribly wrong. I'm going to like lead or elect myself to own the clicker. Okay, so we're going to open with a story because stories are great. This image here, this is the aftermath of an event called the Great Molasses Flood. This occurred in 1919 in Boston. And what has this got to do with ethics? So this was a time when I think kind of the world of civil engineering was a little bit like where we are in computing today. So this was a time when there had been a number of large kind of civil engineering projects that had failed in very, very dramatic ways. So 21 people died in this incident. There was an 8-meter high, yes, 8 meters high wave of molasses, which is 40% denser than water. It's like it's a byproduct of fermenting sugar that you make stuff out of it. So it's 40% denser than water. It traveled at 35 miles per hour. It bent steel girders. It killed 21 people and it injured 150 more. And relief efforts were severely hampered by the fact that they were trying to save people out of a pool of like sticky, goopy stuff. So it was a pretty terrible accident. But it happened at a really pivotal time. It happened after about 4 or 5 very prominent bridge disasters. And there were several engineering societies that had arisen at this time in the US. And they were there's this struggle that was going on, like this political struggle. And on the one hand, you had the employers who were running these sort of big engineering companies. And what they wanted to do was to sort of say, hey, engineers, you guys are technical professionals. You know, we will tell you how we want our bridges and our buildings and our things designed, and you're going to do it. And it's not your business to say whether or not something is okay or not, or safe or not. But a lot of the engineers were taking a very different position, and they were saying, well, actually, we are the people who are the ultimate experts on this stuff. And we need to act in the public interest. We have a higher duty to public safety than to you, our employers. And therefore, it is our responsibility to be professionals. And what I mean by professionalism in this context is to have that higher duty to public safety. So, and there's sort of echoes of this happening right now. So the reason that I did leave Google last year was over this thing called Project Maven, which I'm not going to recap here, but you know, it was sort of a artificial intelligence analysis of drone imagery, and which is not a project that I cared to work on, and nor did very many of my colleagues. There was an awful lot of media coverage about it at the time. But one of the very interesting things that happened after Google said that they wouldn't do the second part of that project was that a whole bunch of people came out of the woodwork and said, well, actually, we don't think that you engineers should really be expressing these sorts of these sorts of opinions. We think that you should essentially shut up and build things for us. You know, don't bully these corporations. So that's a very clear kind of history repeating itself. And so that's why I kind of bring up the struggle that the engineers had.
So professional ethics aren't new. If you ask like 10 different ethics professors where this professionalism comes from, you'll get 10 different stories. So I'm going to choose one that I like the most, because I think it's all about storytelling in the first place. The word professional arguably comes from the word to profess, which Benedictine monks did. They professed their allegiance to God, right? So it was a religious basis. So if you look at these three things on the slide, you've got religion, you've got law, and you've got medicine. There's a really interesting reason that these three disciplines brought on deep sets of professional ethics before most other professions did. So it's because each one has an outsized impact on the societies that they kind of embrace, right? So if your entire life is ruled by religious doctrine, like, religion affects you. And if you're in law, if you are in a society that has a justice system, which we are all in now, the law affects you. Right? If you do something wrong and you have to go through the court of law, or someone victimizes you and you have to pursue that, you're in that system and you usually need representation. So that lawyer has a tremendous amount of power over you. And at some point, you have to develop trust. Same thing goes through medicine, right? The Hippocratic Oath gives you a set of guarantees for someone who has significantly more domain expertise in your own personal health than you do. And you have to trust them, right? So all of these disciplines have a really outsized impact on society. And in order for the public to trust that people have their best interest in mind when practicing their discipline, religion, law, and medicine, they have a set of publicly facing professional ethical guidelines. So I know how my doctor is going to behave. I can expect that. And when they don't do that, they lose their jobs, right? There are plenty of doctors that are not allowed to practice medicine. There are plenty of lawyers. I wish there were more religious leaders that weren't allowed to do that. But there are plenty of lawyers that are not allowed to practice law because they violated a code of professional ethics and they got booted out. And that is what maintains trust between the public and these disciplines. So, so why are we in such a bad place? And computing is really special because one can argue when computing started, right? Is it Ada Lovelace? Is it Charles Babbage? Is it Alan Turing? So I arbitrarily chose Alan Turing sort of start time, right? So 1940s. It's arguable that computing had a pretty decent impact on the world since it helped stop World War II. But one of the things that's really interesting there is that it was a very indirect thing. People didn't know computers were affecting them at that point, right? So in the 90s, when the world started to connect, suddenly computers went from impacting people indirectly to impacting the entire globe almost directly. If you fast forward 10 years, it's very likely that every human being on Earth will have direct, decent access to a global fabric, the internet, right? So not only will they directly interact, all of the technology has the ability to impact their daily lives, right? And that's great and exciting. It's like medicine, except it took medicine 2,000 years to get to that point, and it took us 3 decades. And I've never given a talk like this without cursing, but there's a lot of explicatives that go with that, right? Like, that's a problem. 30 years later, we are now all 30-year-olds in an industry, and we're acting like we're 4, right? So we really do need to have a much more mature attitude and to cope with the fact that we grew up so fast.
Another interesting thing is I think that we actually have a significantly more complicated set of ethical problems in technology than some of our antecedents did. You know, a computer system is not like a bridge. We're going to come back to this later in the talk with a little bit more detail. But think about this now. You know, you're in the shoes of a civil engineer, like worrying about, is my bridge going to fall down? Is it going to be safe? You've got a very relatively specific set of concerns. We have a much larger and more complex set of concerns.
So the shortest possible introduction to ethics. I'm going to zip through this really quick because this is not really a talk about ethics in general. But so virtue ethics. So one thing, this is the first time I've ever given an ethics presentation to a crowd that has a significant number of people who probably have Eastern philosophy backgrounds as opposed to Western. So Western philosophy background, there are kind of 3 schools of perspective into ethics. There's virtue ethics, there's deontological ethics, and then there are consequentialism. So virtue ethics is basically ethics of character. It's ethics of not so much intent, but it's your virtue or your character of your person, and it's much more highly aligned with Eastern religion and Eastern philosophy. Deontological-based ethics are basically rule-based ethics. It's highly Western, like prescriptive, most religious doctrine, like all of these rules to follow. If you follow the rules, you're doing okay, right? I set the rules. You know what? Sometimes bad things happen, but we'll just change the rules to make sure that doesn't happen, but it should be rule-based. It's much easier for people to follow. And I think it's really dangerous when we start to look at ethics in computing because programmers really like rules. We live that. Our compiler works the way it works. We put code in, it comes out, it's great. So I think it's a really dangerous thing to take like a deontological approach to this because programmers also really like to figure out how to get around rules. So I don't think that's very good. I think it's much better, at least at our kind of state as we're evolving here, to either be based on virtues or based on consequentialism, which is like, if it turns out good, it's probably good, right? And I think that's really important, and Laura's going to touch on it some, that sometimes the things we build, we don't really understand how they're going to be used, and they end up being used badly. And the question is that an ethical problem? Bad things are happening. It's an ethical problem. It may not be directly your fault, but we need to build in systems. On the Eastern side, there's a lot of tenets that are around virtue. Right, so this is, they're highly aligned. Some of the things that are really interesting in this case is that some of the ordering of operations are a little bit different. So some questions around more complicated situations, you might find that in the West, you don't think it's ethical, and in the East you do, and vice versa.
I spent a bunch of time I just took a few months off up until about 5 weeks ago when I started on my new job. And one of the things I did was I did an ethics course, as you do. And I started kind of looking at all the debates and all the news that kind of crop up that we all see day to day. And actually, you'll find that a lot of the ethical and political debates, because there's a lot of crossover, it kind of boils down to very often you've got either conflicting consequentialist viewpoints where some people are saying, well, we'll adopt this policy and this outcome will be good. And somebody else will say, but this outcome over here is not good. Or, it will be good for 2 years and then maybe in 10 years we'll have a bad outcome. Or you've got different kind of consequentialist viewpoints where, some people are talking about outcomes, but some people are talking about more of a values-based approach. So, for example, if you look at debates around euthanasia, you'll very clearly see those kind of contrasting philosophies at play. So, There's one final sort of piece of moral philosophy that I think is worth mentioning, and that is Kant and the categorical imperative. And Kant is, like, I think, sort of usually counted as being deontological, and that is really hard to say when you're up speaking in front of hundreds of people. But yeah, he thinks that moral acts are done out of duty. He's very duties-based, and I think that sort of chimes with professional ethics quite a bit. His most well-known thing is the categorical imperative, and what that means is that you should treat humanity as not as a means, but always as an end. You know, every human being is an important universe unto ourselves, and it's not okay to harm one person to benefit another one, or at least not in this value system. So that was nothing to do with cats, and I apologize for all the cat slides. It was purely so we could have this terrible joke.
So I think that setting the context for ethics is very broad, right? So you talk about ethical implications of things. So I like to narrow things down into a common basis where I can almost sort of be a jerk about it, where, you know, like there are a lot of things, if I sit down with someone, we can have a long conversation about life and liberty and the pursuit of happiness, and that's an American joke. And we can disagree. And you know what? It's okay that we disagree. There are a set of constraints which, if you don't agree with them, we don't need to have a conversation anymore. We're done. And those are around human rights. And I think that it's really quite justified. So some bad things happened in the 1940s. The UN got together after those bad things happened and decided that they should establish a universal declaration of human rights for all human beings on Earth. United Nations is the largest body and collection of countries. There is a very high chance that everyone in this room comes from a nation that is part of the United Nations. It is a signed document by the United Nations establishing those human rights. So get on the stick. Like those are the rights that we protect. So when we talk about building things that are good for society and are for the greater good, we are talking about necessarily, not only, but necessarily the maintenance of human rights. The Human Rights Declaration is an excellent read. It's actually an incredibly forward-thinking document for 1948. It was a long time ago, which is a good way to say that ethical constructs do change over time, right? So what people thought was ethical in, 1000 BC versus 0 AD and 1000 AD are very different than they think today. And I would argue that ethics from 30 years ago are significantly different than they are today as well.
And one interesting thing about the Declaration of Human Rights is it does come very much out of that sort of Kantian, human-centered viewpoint of the world.
And,
sorry, go on.
And I will say that we're all hypocrites in it as well, right? So there are no nations as a part of the United Nations that I'm aware of that haven't violated human rights, right? So one of them is you can't torture people, right? I come from the US, absolutely ashamed that we have tortured people, right? Like it's a huge problem. Try not to pick on any countries because I would like to fly home. I'll pick on my own country so that I have a problem re-entering. So I mean, these things are really big problems. The point is not to judge everyone on them. The point is to set a common compass so that everyone in the room, when we're discussing things, knows where we should be going. We should all be pointing at the same goal.
So we're going to get a little bit more concrete and look at a few case studies. We're not going to talk about the trolley problem because I know everybody is sick of it who has ever thought about ethics ever. But The Good Place has a very good episode about this, so I'll refer you there.
There's no real answer to the trolley problem anyway.
There are merely different perspectives. Okay, so science fiction. Who likes science fiction? Hopefully many of you. Okay, this is Ursula K. Le Guin, rest in peace. She died, 3 years ago? The city of Molasses. It's a happy, prosperous city, but its happiness and prosperity is founded entirely upon one miserable child who is kept in just abject misery. And through some unclear mechanism, this fuels the utopia that is the rest of the town of Molasses. So people grow up unaware of this, and then as they come of age, they're told about this. what are the sort of the philosophical implications of this tale? Most people, it turns out, and Ursula is, or like Le Guin was, cynical but probably realistic. Most people will say, okay, well, this is not great, but it is what it is. And then some people, they walk away and they, leave the shining city of MLS and they go somewhere else. So philosophically, virtue ethics, is it noble and character building to live in this town that tortures this one child? Maybe not. Consequentialism. Okay, we've got the happiness of the many. Does this outweigh the abject misery of the one? Utilitarianism, there are different flavors of it, and they would have very different perspectives on this problem. Like your your straight utilitarianism would say, yep, okay, we added it up, win, net happiness is good. But other variants say that, well, actually, there's an element of fairness, and abject misery for one person does not. It does actually outweigh the marginal benefit for others. And there are many lessons that we can think about this from technology. I mean, very often we may build systems that may, kind of a little bit infringe on privacy or a little bit sort of steal the attention for a lot of people to enrich, one rich tech CEO. Is that okay? Mm-hmm. So that's MLS. Here is another one. So 9/11. I think everyone in this room looks like they're probably old enough to remember 9/11. I was doing an internship in university when this happened. So in 2003, the German Supreme Court struck down a new law that the German parliament had introduced just in the wake of 9/11. And this law said that if there was a hijacked airliner, it was okay for the German military to shoot it down before it could do something like 9/11. So this went to the German Supreme Court, and it was actually struck down. They said that this was not okay under the German Constitution, because the German Constitution has a clause that says guarantees human dignity, basically. And again, very Kantian. So it was struck down. And this is another really interesting case study. Different people, different societies are going to have different perspectives on this. And I'm pretty sure that there are places in the world where the law says it's okay for this kind of an operation to happen. It is okay to shoot down a hijacked plane in some places and not in others. So sort of an interesting case study for how different societies can have different perspectives on the same question. Tech, moving into tech. This is the control screen for the SREcon19, and I think anybody who's ever done any sort of technology ethics course will have seen this. Very quick recap. The SREcon19 was a radiotherapy machine. It had two operating modes. So it had a high energy mode, and in the high energy mode, you're supposed to have this beam flattener device that sits between the patient and the radiation source. And then it has a low radiation mode, which was designed for doing radiation that was closer to the surface of the body. And this was intended to operate without the beam flattener device. So two modes. There's a danger here. If you zap somebody with the high dose of radiation without the beam flattener in place, it could kill them or severely injure them. And this is, in fact, what happened with the SREcon19 at least 6 times. So this is sort of an engineering safety ethics question. So what exactly happened? It boils down to an integer overflow, which is unfortunate. But there were some concurrency bugs and integer overflow bugs, which could lead to a patient getting the high beam without the beam flattener. So what are the ethical questions about this? There's a really good paper by Nancy Levison, which we don't have time to cover all of the details, but two of the big things that come out of it are that the company that produced the SREcon19, the previous model of this device had a hardware interlock that made it physically impossible to use the high beam without the beam flattener. They removed that in the 25 because they, frankly, were probably wanting to save money. It's cheaper to do this just with software, right? They had judged the risk of irradiating somebody with the high beam to be outrageously low, like a number, like 1 to the power of minus many, many, many things. This was unrealistic. They didn't really have any good way of assessing that risk. I mean, you can't sort of walk around your piece of software and, test it physically like you can components of a bridge. It's much less definite. And this is a problem that we haven't solved today. We still have these kinds of issues. And then thirdly, they did a very poor job on following up the initial reports. So they could potentially have, if they had followed up more responsibly, saved some of the subsequent patients.
So also on the technical ethical side. And normally in talks I don't name names, but in ethics talk I always name names. And there are more businesses than this. So I like to pick on Uber more than anybody else, just because, well, you can read it all yourself in the news. And this isn't to say that I know many Uber engineers who are absolutely upstanding people, but the culture in Uber as a business was to literally move fast and break things, right? It was more that than Facebook was. Their goal to get into cities was to get into cities even if the law wouldn't allow them to. They intentionally obfuscated their information to avoid regulation, did all those sorts of things. And what's kind of crazy about that is that when you think about having one bad actor in an organization, there will always be unethical people, right? Getting a self-driving car on the road takes 100 people at least. There's hardware design, there's laws that you have to get through, there's licensing you have to do, there are people writing the software to put them in. And when it's on the road, all of those people know it's on the road because they're getting the data and they're making it work. So in what context do 100 people decide that it's okay to drive a car through San Francisco without a license near a school without a driver? Like, that's just stupid, right? There's literally no excuse for that. And I will say that there are occasionally times when the laws are not very good and that we should probably break them. But that's really almost never the case. Like, one of the duty-based ethical concerns is that we live in a society. Our society is regulated by laws. That's why we have a justice system. So it is your duty to not be breaking the law. So if you feel like you need to break the law, maybe you should kind of step away from the problem. Another one is Tesla. So, and I think Tesla, this is a much more problematic one, right? So Tesla cars, you've, I'm sure, seen that Tesla cars have run into objects and killed their drivers. So in order to detect things, it's pretty common knowledge that you need LiDAR. Like, without LiDAR on a moving object, you cannot detect whether or not you're going to collide with another object. Tesla only has cameras on it. LiDAR would be too expensive. And one could argue that says, well, if a human can do it with their eyes, then a car should be able to do it with their eyes. It's like, engineering says you need LiDAR to be able to do that. So what can you do with a camera? I own a BMW. I have a camera-assisted driver, right? It can look, it can see things, it can slow my car down, it can warn me, it can keep me in my lane. It is not an autopilot, right? I cannot set autopilot and leave my car to drive itself. You cannot do that with a Tesla either, but they call it autopilot. So you're actually, this is almost just an advertising problem. There's no problem that people are building tech to make a car safer and drive safer and be smart, right? The problem is that they're taking that and they're leading consumers to believe that it's actually an autopilot because it's called autopilot. And then people are taking their hands off their wheel, they're disengaging their senses, and then they're running into trucks and dying, right? So this is a huge problem. The question is what do you do as an engineer about that, right? You didn't build anything unethical, but it turns out that you have built something that is being used unethically.
And, you know, being honest and being accurate about the capabilities and the safety and the reliability of the systems that we build and run is fundamental to professional ethics. And that's true for the systems we build. I mean, has anyone ever felt like an SLO was being you know, inflated a bit by business? You know, Azure will just hand out service credits. Yeah, it's not great. I mean, it's not on the same, probably not on the same kind of level as people running into a truck and dying, but you know, if you overrepresent the reliability of your service and say ambulance drivers decide to start relying on it to, you know, to dispatch calls, you know, that could end up harming people. We do have a responsibility to be accurate and honest about the reliability of our systems. Okay, so we've done a quick sort of run through of the very, very basics of moral philosophy. Now for history of technology. And kind of one of the fundamental questions is technology neutral? And a lot of people, they like to say it is, right? They say things like, oh, well, you know, guns don't kill people, people kill people. True, but in a country with a lot more guns, a lot more people tend to die of gun death, right? So here is a sort of a classic quote from Neil Postman. Every technology has got inherent bias, and it does. We'll look at the case of the clock. So clocks, not that interesting, right? Actually very interesting. So the development and the sort of the proliferation of the mechanical clock in Europe was very much driven by monks in medieval times. And they were like, yay, clocks. Clocks are great because they will help us to pray at accurate times, and we can ring bells, and we can tell people when to come and come to services. But what actually happened was people went, ooh, clocks. Now I can have all my employees come and work specific shifts in my workshops, and it's one of the things that led to industrialization and people moving into cities, and you know, in many places, the increased secularization of society. So, you know, over the very long run, it had pretty much the opposite effect of what the monks intended.
The irony of automation.
A very different one. Yes. So is a computer system like a bridge, right? And I think no. A bridge, you can directly, physically inspect it. It's very difficult to physically directly inspect computer code, especially if you're not being given it, right? If we start talking about things like machine learning models, I mean, nobody can physically inspect those and really understand their behavior. Computer systems, they're still largely living in a lawless space. You know, there is still a lot of places that are not regulated in terms of behavior of these systems. Speaker notes. Rules about whether or not your computer system is safe, they don't derive in a fairly direct way from the laws of physics in the same way that a lot of civil engineering kind of safety stuff does. And here are a couple of big things. A computer system can be changed and put to really, really, really different uses, like really fast. Like, we're not going to tell the story here, but Theo spoke last year at SREcon19, and he used the example of Uber's Grey Ball project, which started out as a way to keep drivers safe from potentially abusive passengers and ended up as a way to fool the regulators. So, you know, very few changes to a piece of code can make it do something very different. And then, of course, you can arbitrarily copy and scale up software, which is not so easy to do with physical structures. So these are some of the reasons that I think that we have a much more complex set of ethical issues in technology.
Don't use Bitcoin. So the idea of doing proof of work for basic interchange, when the work, I saw a tweet that a single Bitcoin transaction on the public blockchain takes 4.7 gigawatts now. Like, you're a jerk. Like, I mean, we already have warming issues, right? So we have climate change problems. And there's still this drive to have like extreme increased energy usage to do financial transactions, which, I mean, to me, that's pretty simply and fundamentally an unethical approach to the problem. Proof of stake is actually free, so I mean, it's not like the concept is broken; it's the mining part that's pretty broken. Oh, yeah.
Bitcoin, by the way, it uses about the same amount of electricity as the whole country of Ireland, where I'm from. So there's a fact. Okay, so immigration and customs enforcement in the US, they've been much in the news over the last couple of years. So one really interesting point that I want to make about their stuff is in 2017, they changed their system. They have this expert system that their case officers can look at and decide whether or not to detain an illegal immigrant until their trial. So should they post bond, or should they be kept in, you know, a pretty nasty prison that they keep these kinds of offenders in? So a certain president was elected in a certain country, and you know, with certain prejudices that he has, and he said, okay, we will have zero tolerance for this. And so very quietly, without a lot of discussion, that expert system was changed so that 100% of the time it would say detain. And that is a computer system being used as an organizational and social lever. very quietly. It's much easier to go and change a little bit of code. You just need one engineer to go do this, rather than to have that discussion publicly and convince thousands of workers to change this policy. Putting computer systems in these kinds of positions of decision-making and power, they're not transparent, and they're very easy to make these kinds of changes. And this is one of the reasons that, on the first couple of second slides, it mentions that I campaign against killer robots, autonomous weapons systems, and part of the reason for that is I really worry about what happens when we put fleets of drones or armed submarines or what have you into the power of potentially a very small number of people. It's centralizing power in ways that I really do not like.
And highly related to that, the justice system has issues. It's very similar to ICE in that when you change a computer system, human beings are really good at delegating decision-making to computers. I don't know how many times you have trusted your tool's output. That's exactly what that is. It's just trusting your tool's output. You're given a tool, you're told to use a tool at work. Even when you select the tool yourself, when you run it and it has an output, it actually takes a lot of work to be like, I think that's a lie. I think that's wrong. All right, so by changing in the ICE system, by changing to 100% rejection rate or detention rate, you didn't have to convince anyone to do anything. They were already predisposed to trust the tool. In the justice system in the United States, we have some software, it's not ubiquitous, but it is in a lot of places, that tries to, it uses ML and AI to analyze historical data to understand what the likelihood of someone breaking parole or recidivism into crime. And it turns out that we have a pretty stacked system due to some big challenges in the United States over the last 200 years. Many countries have these same problems. So all of the data that you train on is a product of all of the systemic bias in the system already. So you are building a model where you're guaranteeing that you have systemic bias built into the model. Now, there are some really interesting ways to correct for this by building tests to understand and analyze how biased it is, but those tend to not be done, especially in this system. So it turns out that African Americans in the United States are more likely to be rejected for parole or have longer sentences because the system predicts that people like them have longer sentences because human beings gave them longer sentences because they were racist. So it's a huge problem, and once you've given someone a piece of software, they're inclined to trust it, and they don't question it. So as engineers, it's our responsibility to not give that type of software to people.
And as well, there's another facet here, which is that this can be a sort of a vicious cycle, right? If I say, well, people with beards, they're far more likely to commit more crime if I let them out on parole, right?
It's true.
So I'm totally not going to let Theo out, right? Theo is going to lose his job. He may get kicked out of his house. He may lose all his stuff, and now his life is in a far worse place. And because this system made this decision, he may actually be more likely to commit another crime. Sorry, Theo, just your handy example. I
am a handy example. Got to pick on Facebook. I've been hanging out with all the Facebook guys. So where to start? My democracy's in shambles, and some president got elected. I'm sure that doesn't have anything to do with Facebook. Maybe. No, but I think that when you have a really big system with an outsized impact and power on society, which is exactly what Facebook is, right? It connects billion people together, right? So it's an outsized impact on society. So, what did they do 15 years ago for this? What did Facebook do 15 years ago? I don't think they were there. There was no Facebook 15 years ago. So they've had to grow up. I mean, I don't know how old is Facebook, 12, 11 years old, something like that? I don't know. Would you trust your 12-year-old with the fate of humanity? Because I have a 12-year-old and I would not. She's wonderful, but it's kind of an outsized power to have because she hasn't had an ethics class yet. Probably still wouldn't trust her even with an ethics class. You don't trust one person with that power. Facebook engineers have a responsibility, and all engineers at every company have responsibility, but specifically Facebook, to forecast with a crystal ball how the technology they are building will be used, because it will be used on everyone. It's a very important thing, because sometimes you can damage a democracy or ruin a country or whatever. The other times you can have things like the Rohingya issue. Like, pro tip, we didn't have a name for genocide before 1940. There wasn't a word for that. That's how acceptable that was societally. In the Middle Ages, when you attacked a village, you killed everyone, because you don't want them growing up and coming back at you. We don't do that today. It's against the Geneva Convention, right? You cannot do that. So those ethical standards have changed. So when we see things like genocide now, we see them as what they are in our current context. We see them as abominations to humanity, which they absolutely are. So I have a lot of empathy for the Facebook engineers that were close to that, because I don't know how I would sleep at night. I don't ever want to build a piece of software that doesn't let me sleep at night. I ran businesses that didn't let me sleep at night. I'm done with that. I want to sleep.
Yeah, personally, I lost a lot of sleep last year. It's not nice. Okay, so it turns out that here's data. Everyone loves data. We mostly want to do the right thing. There was a Stack Exchange or Stack Overflow survey done last year that asked about ethics for the first times. So the good, 80% of technologists say that we want to do the right thing. We have an obligation to consider the ethical implications of our work. Now, it gets worse from here, because only 50% of us would report unethical code if we actually saw it. So, we have good intentions, but we don't follow through necessarily. So apparently 40% would write unethical code if asked to do so, but we'd feel bad, probably, some of us. But only 20% would actually feel responsible for the unethical code. And this is something that Theo talked about a little bit. How is it that organizations of hundreds or more engineers wind up doing bad things? And I think this is sort of a bug in humanity, right? We have this great ability to sort of diffuse responsibility across a large group of people. Hey, we're doing something bad, but there's a lot of us in it. I don't want to be the tall poppy. I don't want to put my head up over the parapet. Everyone else is as equally culpable as I am. And I think that that is wrong. We need to consider ourselves individually culpable for the bad things that our organizations are doing, and do what we can about it within the bounds of what is safe and reasonable for us to do, because we're not all in the same kind of privileged position to take action.
I would say that be the change you want to see in the world, until I read that 1 out of 5 of you don't care. So that's a little disturbing. I hope that that number is not representative of this community, and that 20% of us less than 20% of us, as I say, 20% feel ultimately responsible for their unethical code. That's a scary, scary number.
Yeah, this is kind of the problem,
So why you guys? You all. Why you all? Honestly, there's two sides to this. One, it's not all of you, right? It's all of everyone in this industry. It's all software engineers, it's all operations people, it's all SREs, it's every single person that has the ability to make a computer do something needs to have an ethical compass around guiding what they do and what they have that do, right? The unique thing about SREs is that companies that hire SREs tend to have products that touch a lot of people, and you tend to be the choke point of delivering that service. So you are in a very special position where you actually get to see who the product is touching and what it's doing. You have kind of a outsized visibility into how the platform operates, and with that outsized visibility comes an outsized responsibility. You have, I will argue, more responsibility because you have more visibility into the problems. So what can we do? So I think there are two really important topics. One of them is the ethical review process, and the other is dissent. I'll get to dissent in a second. but the ethical review process. So like if I have one actionable outcome from this talk, it's that you think about ethics. Like as you build the things that you build, you actually consider, would this enable violating anyone's human rights? Does it erode any of their rights? On the flip side, does it help cement anyone's human rights? Does it help people maintain their rights? These are things that are really important. So what I would love to see is actual industry change that incorporates an ethical review process into the software development lifecycle. There's security reviews, there's privacy reviews now. It's pretty close. It touches on the edge of ethics there. Well, it's more than touches on the edge. It's part. It's just an incomplete picture of ethics. So the idea of saying anytime you go build a piece of software, anytime that software is going to be incorporated into another system, how is this going to be used? Who could do damage with this? Is this dangerous? Those are the things. These are safety considerations. And your job is a lot harder than a bridge maker, because the bridge maker, bridge designer, architect, construction company, they have one concern. Is the bridge going to collapse under pressure, right? Are people going to die on my bridge, right? They're not really worried, is this bridge going to be used by an invading army? That's not a common concern. And if it is, the same people who were evacuating the city are going to go over the bridge anyway. Still has to work.
You can always blow the bridge up.
You can always blow the bridge up. Software can be copied infinitely many times, so once it's out in the world, you can't really take it back. So I think it's really important there's no like simple answer to this. Just asking the question and thinking about it is not enough, but it's a critically important first step. Like if you start to contemplate the ethical concerns of what you're doing, your behavior will change. It's one thing for 10 people to go do something unethical. It's another thing for 10 people to really talk about how unethical it is and then go do something that's unethical. Like, we're all human. We don't want to do that. The second thing is, I'm a member of the IEEE and very critical. I'm not a big fan of the IEEE. One of their best documents is the IEEE Guideline for Engineers Dissenting on Ethical Grounds. This document is so down to earth, all right? So I know a lot of people who say, oh, if my employer asked me to do something, I'd just quit my job. I'm like, you don't have kids, you don't have to eat. Like, you can't just go quit your job sometimes. Sometimes you are in a privileged position where you can do that, but it doesn't mean it's the wrong decision to not do that if your personal livelihood is put at stake. So this document, we're not going to run through all of it, but I recommend reading it. Gives you kind of a step-by-step back-off on rage quitting all the way down to cooperating and documenting things so that you have a paper trail to take somewhere for legal action or protection and things like that. So if you see something, read the document and try to follow the path that suits you best. And it's very important that you are never under an obligation to put yourself in personal danger for ethical reasons. You can choose to do that, but you're not ethically responsible to do that. That would be a violation of your human rights.
What I will say is sometimes it's not as bad as you think. I mean, certainly if you live in a relatively free country in the West and, you know, it's all, you know, you're not worried about being sued or put in jail. You know, I personally thought I was doing my career enormous damage by quitting Google last year to dissent. But in fact, I'm actually pretty happy with how things have worked out. So, you know, we're lucky in that we are so in demand right now that we have a bit more freedom to do this, or at least many of us do. Something that I think is important is we are by and large in the technology industry completely ununionized. Some of us may belong to an organization like the ACM, many of us do not. Very few of us belong to any sort of a trade union or trade union-like organization. I do. I'm one of very few. I think that it's something that I would like to see gain more traction in the industry. It gives a degree of individual protection against, you know, routine bad things that can happen to us in our careers, like, you know, bullying or whatever. And it is something that could over time lead to having a sort of a seat at the table in terms of what our businesses are doing. You know, people have been trying very hard in a lot of the public companies to put brakes on as shareholders, and many employees are shareholders. But labor organizing is another route to this. This is really complicated stuff, right? We swim in some very dark waters, particularly right now, particularly in this industry. Like we're at the sharp end. The way those civil engineers were, you know, sort of in the early 20th century, dealing with these collapses and these, you know, these sort of molasses floods, right? And again, we're not going to tell you what your values should be. We're asking you to think about what your values are. We're asking you to think about the products that you're building and running and contributing to, and, you know, think about feeling some responsibility for that. Organizational processes, we need to start having these as standard in our industry. You know, we can't sort of go around, you know, willy-nilly like Deadpool sort of flinging grenades around anymore, right? We need to start being more intentional about the work that we do.
And I said I wouldn't read the ACM Code of Ethics. And
That's
I
the
won't.
good bit of it.
I won't. It's an excerpt from the ACM Code of Ethics, focusing on the last line. This obligation includes promoting fundamental human rights and protecting each individual's right to autonomy. There's a lot of that. It's about using your skills to do that. The document's pretty long. I will say that the document from 1982 was incredibly dated. They just revised it in 2018. It's a pretty well-founded, well-reasoned document. It's not like over the top, you have to love everybody or anything like that. It's just a set of professional ethics on producing quality product that benefits humanity. That's your obligation as a professional. For what it's worth, that's not just computing, right? Like this one is a computing specific one. It deals with a lot of like the authorship of code and product quality and things like that. But every professional, that's what it means to be a professional, is to have a set of code of ethics. It is a fundamental part of being a professional. If you do not have a code of ethics, you are simply not a professional SRE or a professional software engineer or a professional. Every single industry, electrician, dentist, everybody who's a professional has a set of ethics. International Brotherhood of Electrical Workers in the United States is the trade union that's electricians. They have a code of conduct. They have a set of ethics. Everything's great. So one of the things that I'll leave you on about trade unions and societies and things like that, the ACM is the oldest, it's actually the second oldest society representing our industry as a whole. Has about 100 plus thousand members around the world. I highly encourage everyone to participate. I actually highly encourage everyone to tell their employers to fully fund and pay your membership fees. They need you to be a professional too. And one of the reasons that I really like that is that one of the things you don't get to choose when you join the ACM is that you agree to this. And if you work with other people who are ACM members, you know that they have also agreed to this. And it provides that compass that points in the same direction. You know that the person you're working with has this stuff, and if they violate it, you can report it to the ACM and their membership can be rejected, which is a nice, soft construct around that. So my dark world future is that all the big companies decide that you have to be an ACM member to work there. And then it's not soft anymore when you get kicked out of the ACM for violating the Code of Ethics. You lose your job. Like a lawyer who screws a client, or like a medical professional that does a procedure that the client didn't ask for or didn't want, right? All of those people lose their job and they lose their right to practice. So I think that with computing's outsized impact on society, we really need to get there. And I hear Silicon Valley already with their pitchforks trying to burn everything down at me saying that. But we really do need to get there where society can actually trust us to do what we say we're going to do.
I'm going to leave you with this. You believe in defense in depth for reliability for your services, right? We need defense in depth for ethics in our field. And that defense in depth is you, every single one of you. Keep up with the conflicts and the controversies in our field, and think about things. Be defense in depth.